GCSE Physics Boosters, Introduction to Energy. Energy comes up in GCSE Physics an awful lot in A-level physics. It's a very important topic. It's very important that you understand energy. So we're going to cover loads and loads of videos about energy. This is just a little introduction, pretty basic stuff, hopefully. Now, what is energy? That's quite a difficult question. Basically, because there's so many different types of energy. If you look at all these pictures, they all represent a certain type of energy. Do you reckon, maybe pause the video, what type of energy does each of these pictures represent? And I'll show you the answers in 3, 2, 1. Okay, hot potato, thermal energy. Yes, we've given it heat energy in the oven, and now it has lots of internal energy or thermal energy. Person on the motorbike whizzing along, kinetic energy. Things which are moving have kinetic energy. Petrol has chemical potential energy. Food also, that's where we get our energy from chemical potential energy in the food that we eat. This lucky bloke's got a Marshall stack, amplifiers and speakers making lots of sound, and sound carries energy. Waves, all waves carry energy. Bottom left, gravitational potential energy. The water at the top of the waterfall is high up. It's got gravitational potential energy. Light is a wave, and so it carries energy. The batteries inside that torch have got chemical potential energy. Elastic potential energy is when you stretch something, when you change the shape of something, an elastic object, you're giving it elastic potential energy. And then electrical energy. Each of these we're going to talk a lot more about. I mean, we're going to do a whole topic on electricity. We're going to do several videos about elastic potential or elastic energy and springs and things. A few facts about energy. Energy is measured in joules, which is capital J. If you've got a lot of it, then kilojoules, megajoules, gigajoules. Energy may be transferred from one form to another. That means it can be changed from one form to another. An energy transfer, we'll talk about a few of those on the next slide. An energy transfer is when it changes from one form to another. The total energy of a system is constant. A system means an object on its own or a group of objects. In other words, whatever you're looking at, there's nothing else involved. That is the system. And the total energy of a system is constant. We'll do a video about that sentence later on. It's called the principle of conservation of energy. Very important in physics. What is energy? Energy is what something has which enables it to do work. The next question, what is work? We'll talk about that later. But basically, if something has energy, then it can do work. Who's this fella? This fella's James Joule, and he was the manager of a brewery somewhere in the Midlands. Okay, and he was also very interested in science and mathematics as well, and he did lots of clever experiments to do with heat and work. Originally, apparently, he was interested in making accurate thermometers, which would help him brew better beer. But he was actually a very clever bloke. He did lots of important experiments, and energy is named after him. In this topic, we will learn how to calculate how much energy an object has. Do that in the next video. And we will look at certain energy transfers when one type of energy changes into another type. Look at all these pictures. Can you see an energy transfer? What energy transfer does it represent? Okay, energy before, energy after, that's your energy transfer. We're not going to look at them all, but Here's an example. Which of these pictures shows chemical potential energy being transferred into heat and light energy? And if you like that, those boxes at the bottom, that's an energy flow diagram, you could call it. And of course, the answer is the candle. Potential energy. I've used that phrase a couple of times. You can think of potential energy as being stored energy. And here's three examples here. The water in a dam, and that is storing gravitational potential energy because the water is high up. Lots of heavy water high up, okay, stores gravitational potential energy. And at some point, if you need electricity, I believe that's the Hoover Dam. So if Los Angeles needs a bit more electricity, then you can convert that, you can transfer it into electrical energy. The middle one is a wind-up toy, and if you tighten a rubber band or a spring, then it is storing elastic potential energy, and when you let go, here it's changing into kinetic energy, amongst other things. And then the petrol in this petrol can is a store of chemical energy, chemical potential energy, stored energy. Let's finish this video with a question. In this picture, space shuttle taking off, any kind of a rocket taking off, but look at the picture. How many different types of energy are represented by this picture? Okay, write a list for yourself. I'll show you my list in 3, 2, 1. Okay, heat energy. That gets very hot. I wouldn't stand underneath that if I were you. It gets very, very hot, and it's giving off lots of heat energy, radiant heat energy as well. Light, it's very, very bright. It's giving off lots of different types of electromagnetic radiation, actually. Kinetic energy, this thing is accelerating, it's speeding up, it's gaining kinetic energy. It's also gaining gravitational potential energy as it's getting higher and higher. Sound, apparently when these things take off, you're not allowed to be within 3 miles of it because the sound would kill you. I mean, at least that's what they told me when I was at Cape Canaveral watching one of these take off. So all of the audience is at least 5 miles away. When they take off, they have a sound suppression system. All the water spraying at the bottom when it takes off is actually to cut down the noise, because the noise is bad. And then chemical potential energy in the rocket boosters, in the main fuel tank, lots of chemical potential energy